Okay guys, last one, same type of problem, just it's a different function, one that will require a little more work than the last one. But fundamentally it's the same. Really the extra work here is going to be factoring at the beginning. The numerator factors by grouping. X cubed and negative 4x squared share an x squared times x minus 4. These share a 1. 6 minus 4. The denominator factors into x minus 4 and x minus 2. Now remember, they share these, so the two factors are x squared plus 1 times x minus 4. You can pull the x minus 4 out, and what's on the outside is left, over x minus 4 and x minus 2. This one is different because notice that these share 4. So what does that mean? When x minus 4 equals 0, when x is 4, we have 0 divided by 0. So you cancel them out, it'll create a whole at x equals 4, but you can reduce the function to x squared plus 1 over x minus 2. To find the y value that goes with the whole, we have to plug in 4 to what's remaining. So f of 4 equals 4 squared plus 1 over 4 minus 2. That's 17 halves. So you have the point 4 17 halves is a whole. So I want to see what it looks like when we do this. 17 halves is 8.5. So we have 1, 2, 3, 4. 1, 2, 3, 4, 6, 7, 8. 8.5. So we put an open circle here. That's what a whole will look like. Now let's find the rest of the features. We only have to work with the rest of the function now. That's the x squared plus 1 over x minus 2. Vertical asymptote, x minus 2 equals 0, so x equals 2. So we have a vertical asymptote at x equals 2. The numerator has a larger power than the denominator, so we have by exactly ones, we have a slant asymptote. So I need to take that 2 and divide it into my x squared plus 1. Remember to leave a 0 in your synthetic division to handle the missing x term. So 1 comes down, 1 times 2 is 2. 0 plus 2 is 2. You don't care after the remainder, so this gives you the line, or after the second term, y equals x plus 2. That means we have a slanted dotted line that starts at 2 and has a rise over run of 1. So roughly like this. So we've got this dotted line, y equals x plus 2. Now, let's go back to the math and then we'll come back to the graph here. Besides that, we have the intercepts. So for the y-intercept, we'll plug in 0, which means we will do 0 squared plus 1 over 0 minus 2. So that's 1 over negative 2, which is negative 1/2. Of course, this is the point, 0, negative 1/2. Make a full dot there. And lastly, the x-intercept, we set the numerator equal to 0. Well, when is x squared plus 1 equal 0? Here's a question. X squared is always 0 or positive, and so when you add 1 to it, it's at least 1. So this never happens, so there are no x-intercepts. That means there's no point on which that I actually cross the axis here. So the only place I can do it is at asymptotes. Now, we only have one asymptote, and that's at x equals 2. So when I do my critical values, the only one that I have is 2. So I need to pick a number less than 2, like 0, and a number bigger than 2, like 4. Guess what we already did? For the whole, we already plugged in 4 and got a positive number. For 0, we already plugged it in for the intercept, and we got a negative number. That means all of the values to the left of 2 are negative, which means they'll never cross the axis here, and all the values to the right are positive. Now they still have to curve towards the asymptote, so the only thing left for us to do is to curve down towards the vertical asymptote on the left and curve towards the slant on the left as well. But on the right side, it's all positive, so we have to be curving up and still curving towards the slant. So that was actually kind of a nicer problem by comparison because there was less to plug in, but it's the features that are the most important, so keep that in mind, and I will talk to you guys next week.